Hello everyone, this is Professor Amit Solanki. Now today's our topic of discussion, that is the braking. Braking of the motors, or we can say that the electrical braking, right? As you know that, what is the meaning of braking? Generally braking are two types, one is electrical braking and second one is mechanical braking. So in this lecture, we will just go through the electrical braking, not any other braking. Okay. So braking means to require the stop the motion. As you already know that in our daily life, what are the importance of braking brake system in our transportation system, in our industrial DC motor drive, AC motor drive system, electrical drive system. So braking is very important. So in case, let us understand the concept of the braking and their types step by step, one by one. We will discuss the types of braking also. So in electric braking, the motor is made to work as a generator, producing a negative torque. The electrical braking may be required due to the following reason. If so, we can see here, we can observe here what are the reasons for applying the electrical braking. Okay, so there are some reasons in that we will apply, we can use required the braking. First reason is that if a motor running at some speed, okay, if a motor running at some speed is disconnected from the supply, so the only opposing torque will be the load torque, that is T of L. The motor will stop only after the kinetic energy stored in its inertia is dissipated. When neither the load torque is small or the inertia is large, the motor takes a long time to stop. In applications requiring frequent stop, the stopping time must be reduced by introducing additional opposing torque by the use of electric braking. Okay, that means, for example, we can understanding in local language in a simple definition, like if suppose in our house one ceiling fan is running at their high speed, okay, and if we are directly switch off from their main supply, then what will happen? The fan is not directly, not suddenly stop, okay, it will rotate at their own place by the due to some inertia. So for that, in some application we required immediate stopping or urgent stopping or exact stopping. So for that we require the braking system. For example of lift, conveyor, in that lift we require the particular place of stop and reliable stopping. For example, if we have required to stop in second floor, third floor, so this is the function of the lift, or we can say that the conveyor. So according to that, this is the one of the most reason to require the braking system. Second application, second requirement need is that in some applications such as traction, rapid emergency stops are essential to prevent the accidents. So thus, the electric braking helps in achieving quick and smooth stop. So this is the second reason for that we require the electrical braking. These are applications where accurate stops are required, such as in lift, we have already discussed earlier in previous slide, machine tools, ingot, buggy control, and a screw-down mechanism in the rolling mill. These are the applications, these are the reasons for that we require the electrical braking system. Electrical braking, electrical braking allows Electrical braking allows accurate steps without subjecting the mechanical parts only large stress. So these are the reasons. According to that, we can require the electrical braking. Fourth reason is that in certain applications involving active load, the drive speed will reach dangerous values if the braking force is not provided by the motor. These are the also one of the most reasons for that we require the electrical braking. For example, in a hoist application, when a loaded hoist is being lowered, the motor should provide a braking force to hold the speed within safe limits. Similarly, in traction system. Okay. When a train goes down a steep gradient, a braking force is required to hold the train speed within safe limits. That means if train is going or moving into the hilly areas to stepping down gradient, okay, goes downside. So there is speed is increasing automatically because there is a step down. So for that, in that we required the controlling the speed of the for the safe limits. Okay, and the braking force can also be obtained by using mechanical brake. These are the also specification of braking. As we already told that brakings are two types. One is electrical braking and second one is mechanical braking. However, this leads to wear and tear of the mechanical part. It is not as smooth as electrical braking. So if we are consider that if you are talking about the other types of braking like mechanical braking, so in case of mechanical breaker there are chances to wear and tear. So for that we are not discussing about in the more details about the mechanical braking. So electrical braking is smooth, reliable as compared to mechanical braking. For sometimes for some applications also mechanical braking is also required. For example, in case of two-wheeler, four-wheeler, okay. In two-wheeler, we have already seen that we have observed that there we are using the mechanical braking and the mechanical braking part as the brake shoes, okay, drum. These are the parts for the mechanical braking. Furthermore, by using regenerative braking explained in the next chapter or next lecture, the energy usefully employed instead of the being wasted as with mechanical brake. Okay. During braking, the motor essentially works as a generator. Okay. With the direction of current shown, in the steady state equivalent circuit figure 2.2, the machine develops torque in the positive direction and converts the electrical energy into mechanical energy, which is absorbed by the load. So this is the most of the in that chapter we will discuss about the braking of the DC motor. Okay. If by some means the motor armature current is reversed while maintaining the flux in the same direction, the motor torque will reverse and the machine will work as a generator. Okay. Now the braking operation is classified in accordance with the manner in which the generated electrical energy is disposed of. So there are basically three types of methods for the braking of the DC motor, in which they are first one is that is the regenerative braking, second one is the dynamic braking or rheostatic braking, and third one is the plugging or reverse voltage braking, or we can say that is the counter current braking. So one by one we will discuss the different types of brakings for the DC motor. Okay. So conclusion is that the main concept of the braking is to stop the motor or to create the negative torque against the speed of the motor. This is the basic concept for the electrical braking. Thank you so much.